All right, welcome to part 3 of my 4.3 pre-calculus class. Mr. S here. Okay, we'll talk about cofunction. We're at this page right now, so I'll go back to another part. Sine and cosine are cofunction. Here's the reason why. Okay, they are equal to each other of the 90-degree bank, or 90-degree angle, if you want to call it. So sine of any angle, the angle can be 10 degree, 12 degree. If it's 10 degree, sine of 10 degree is going to equal to cosine of 80 degree because you got the 90 minus 10. Sine of, say, 30 degree, right? 30 minus 90 is going to be 60. So sine of 30 is the same amount, the same length as cosine of 60, and so on and so forth, right? Cosine of 20 would equal sine of 80. Cosine of 60 would equal sine of 30. Cosine of, say, 1 degree would equal to sine of 89 degree, because you subtract them. That's just simple as that, okay? Here is a quick reason why. I made this little chart right here, really fancy stuff, okay? So as you see here, this is your cosine, which is the x. I made this radius being 1 because it's easier. It's supposed to be like 1 times this guy here, whatever the angle is. We talked about that in the last video. So the x-axis is your cosine, the y-axis is the sine. Opposite of the angle, right, is a sine. Sine is opposite of hypotenuse and so on. So that should be 1 down here. Anyhow, now if you turn this around, oh, by the way, this is 90 degree, right? So if this is 10 or 20, 20 minus 90 is 70. So this angle is 70. Now if you turn this way, easy to turn around. So now this is 70 while this is 20. This is adjacent to that 70. So this angle is going to be 70. Cosine of 70 is this length. The sine is the height, or the opposite of this angle. That's why they are called cofunctions. Sine and cosines are cofunction of each other, but it's got to be the difference in the 90 degree, all right? I mean, you have to subtract the angle from 90 degree and figure out what the cofunction of that value is. Okay, so that's what that is. Okay, so we'll look at how the problem is going to be solved or used later on. I'll just add into these here. So let me go back a few slides. All right, so this is just the review of the last time we talked about this thing. So we talk about, I think we talked about the radius of the circle being any length. So this time I made the radius of 6. 5 pi over 3. So where is 5 pi over 3? You have to figure out where that is on the unit circle. So let's see. So this is 3 over 3 pi. Okay, I'm slow here. So there should be 4 over 3 here. Sorry about that, because you count by a third. So this is 1/3, there's 2/3 this way slightly, so 1/3, 2/3 that way, and 3/3, which is 3 over 3. 4/3 should be here, 5/3 should be here. So this length is 6. Okay, so let me reset the board. So this radius is 6, and this angle is the 5/3 of a pi in radian. So this angle right here has, or the point on this circle at that angle, we're talking about coordinate point, should be, let's see, how far is that? That should be 1/2. And how low is this? So 1/2 is always going to be pairing with the root 3 over 2, but since you go down, that should be negative. So this point right here having that length, so this number right here is your unit circle numbers, which is 1 in the front. So if you have a 6 for the radius, so it should be 6 times that amount. And again, you put a 6 in front of a 1/2 or times 1/2, you get a 3. Because half of 6 is 3. And then if you put a 6 here time, or basically you're doing the 6 divided by 2, should be negative because it's going to pick up a negative sign. So negative 3 root 3. Okay, that's how that works. That's a quick review of what we did last time. Moving forward, you can do that with a degree measurement, not the radian, not just for radian. It applies to everything. A couple of these questions here. You don't need the unit circles to solve the problems, okay? I'll do another video on how to apply or when to use unit circles, when to use all these SOHCAHTOA stuff. So the sine, cosine, and tangent. So you can use sine, cosine, and tangent to solve this type of problems. Here, basic Pythagorean theorem should work. Okay, you can set it all up. I don't think I want to go into that part today. This is, I don't think that's Pythagorean theorem, right? I think you can get away with this problem solving for this x right here by setting up the ratio for sine. So sine of angle x would be opposite over hypotenuse, which is 25 over 50. I think I set this problem perfectly for the unit circle, because if you reduce that fraction there, it's 1/2. Okay, so now the question is, what angle when the sine value or the y value is 1/2? So the unit circle, this is 1/2 if this is 1. So the angle here would be 30 degrees. So your answer is solved, just like that. The problem is solved, not the answer. All right? Okay, so let's see, we're at 7 minutes. I'm gonna skip these here. I can come back. We talked about that page. All right. That's for the radian. Okay, I can show you the radian here. Let's see. If I have a sine of, this is cofunction by the way, of pi over 4, or pi over 3. Let's put pi over 3 here. What would that equal to when you have a cosine as a cofunction? So you'll take pi over 2 minus your pi over 3. Of course, you have to get your common denominator, so you have to multiply this by 3 and multiply this guy by 2 to get your 6 in the bottom. So now you got pi over 6 here, or 3 pi over 6 minus 2 pi over 6. I didn't write the pi, but you can just think of it as being factored out. So that should be 1 pi over 6. Hope my number is right. That's pi over 6. Okay? So sine over 3 is equals to cosine of pi over 3. Let's check that on the calculator. Okay? So you can always check it on the calculator. You can switch your mode from the calculator from radian to degrees. So right now it's radian, so I'm pretty happy with that. So I'm going to clear the screen, then I'll go sine of my pi over 3. So pi over 3. See what it says. I always ask you guys to use the calculators to verify your work. And then cosine of pi over 6. There you go. Hope it's the same number. There it is. Alright? So you can do that for all 3 functions. Just pick a random number. You can test yourself out, or you can try to do your own example. Make different angles here. Different angle in radian, and see if you can subtract them. It doesn't have to be one of those angles from the unit circle. Alright? You can say pi over 12, pi over 7 for theta, and subtract them. Just don't forget to get your common denominator. Alright, cosecant. Same story here, so I'm going to skip.